بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. We'll start now chapter 9, and as you can see here, what's the title of chapter 9?
Chemical bonding to.
Molecular geometry.
Yes. Just a second, because I want to start recording. It's already there. So. All right. Okay. Bismillah ar-Rahman ar-Rahim. Yes. Yes. What's the title of chapter 9? As you can see here.
Chemical bonding to.
What was the title of chapter 8?
Chemical bonding.
Chemical bonding 1. Now there's chemical bonding 2. So this this chapter actually is related to chapter 8. Okay. Now we're going to talk about the geometry of the molecule, and how the bond is taking place, the bonding theory. But we'll talk about first the geometry of the molecule. All right? And there is a theory. I want you to memorize the name of this theory very well. It's called valence shell electron pair repulsion. Let's write it here. Instead of writing it here. This is the name of the theory. It's called, very long name. This is the name of the theory. Okay, I want you to memorize the name very well. Valence shell electron pair repulsion model or theory, which describe the shape of the molecule using Lewis structure. Okay, what is Lewis structure? You remember the Lewis structure?
It shows
Yes.
atoms sharing electrons, how they share electrons.
For example, Lewis structure is using valence electrons to distribute around the atoms, and usually the atoms at the end would like to have how many electrons around it? How many electrons usually? The atoms? 8. What was this called?
Octet.
Octet rule. I wanted to know all of these things. This was developed by Lewis and tried to make the Lewis structure. Now, the valence shell electron pair repulsion theory uses Lewis structure to find the shape of the molecule. All right, how is that? In this theory, we concentrate about the two things we have to know. First, any bond, I'm going to call it from now on as B, which means bond. And this bond could be single or double or triple. Or I can draw it, the B, if you see any bond like this, or like this, or like this, all of these, we're going to represent it by a letter B, any one of them. All right? And then, if we have electron pair like this, we're going to call it E. I draw it sometimes line, like, I mean, not line. I should not draw it line. I will draw it electron pair. We're going to represent it by E. All right? And the central atom, which is the one that we're going to talk about, or we're concentrating on, we're going to call it A. So out of this, I'm going to do what's called electron domain. Electron domain. What do I mean by electron domain? How the electrons are distributed around the atom, any atom. All right? For example, if I take this carbon here, I will call the carbon A. And then I have double bond here and double bond here. Each one I will call B. So I have AB2, and then if there is any electrons around it, I will put it E, but here around the C there is no electrons, so I will call it E0. E0, or I don't have to write anything. Okay, let's repeat it with the other molecule here. Let's look at this structure, this oxygen, the one in the middle here. I'm going to call this atom in the middle, I'll call it A. And how many B's around it?
Two.
Huh?
Two, but with different
Yeah,
type.
still, we said if it's single bond or double bond or triple bond, still B2. All right. And how many electrons around it? This atom only. How many electron pair?
One.
One, exactly. Is this clear? Good. How about this nitrogen? Let's try this nitrogen. We're going to call the central atom as what? A. And then how many B?
B3.
B3. And then E.
1.
1. Is this clear? Do you know how to do it? Can we do it for this oxygen? In this case, this oxygen is A. And then how many B?
1.
B1, yes. And then?
E3.
E3, excellent. Excellent. All right. How about this oxygen?
AB2.
AB, no. AB.
1.
1. Yes.
E2.
E2. Excellent. AB1, E2. We call this now, very important name that you must name, and it's called electron domain. Electron domain. Did you memorize the name? Electron domain, which is AB1E2, AB2E1, anything. It depends on the sheet. All right. So in this case, how many? We want now to add the 2 and the 1 and the B and the E. What's the total electron domain in the first structure, which is CO2? We have 2 and 0, 2 plus 0, which is equal to what? 2, right?
Yes.
Okay, in AB2E1, we're going to add 2, which is for the B, plus 1 for the E, which is how many total now?
3.
3. All right, and then let's do for the last one NH3. What's the electron domain for NH3?
4.
4. Why? Because we have 3B plus 1E. 3 plus 1. 3 plus 1. This is the 1 and this is the 3. And the total is 4. 4 electron domain. In addition, we're going also to have 5 and 6. Is this clear? Okay.
Doctor, what do you mean by 5 and 6?
We are going to have, other than this, I'll give you example. For example, let's say that we have S, F, 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 and like this. What's the electron domain for SF4 in this case? A,
B4.
A, B4,
A1.
E1. What's the total?
5.
Got it?
Yes.
We go also to have 6, which is, I'll give you example. For example, if I give you xenon F, 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 F. What's the electron domain? It is what? A,
B5.
B what? B4. E,
2.
2. What's the total?
6.
X. All right. So,
Doctor, what's B and A?
what do you mean?
A and B and A, what's represents?
Nothing. As you said, the A represents the atom that you're talking about. The A represents the atom. So, in this case, for example, I will repeat one more time. Let's take this away. And as I said, this is the electron domain. Let's take about this atom. If I want to know the electron domain of C, of this carbon, then I will call the Ca just to know the electron domain then. And any bond around it, I'll call it B, whether it is single bond or double bond or triple bond. In this case, I have two double bonds. This is one double bond and one double bond. Each one I'll call it B, so the total is B2. And there is no electrons around it by themselves, no pair of electrons. So in this case, I will call the pair of electron E, and I will give it to 0. This is the electron domain. And the most important thing, what's the total electron domain around the carbon in this case? Total, 2. Why? Because I'm going to add 2 with 0 to make it 2 plus 0 is equal to 2. Is this clear? Okay. Now,
Thank you.
Now, let's do one more thing. Let's do it for this oxygen. This oxygen. First, write the electron domain for this oxygen. A, B, what?
AB2, E2.
No, AB, 1. The double bond is 1B, not B, not double. AB1, E2. Is this clear?
Yes.
All right. Now, what's the total electron domain in this oxygen? Total.
3.
1 plus 2. That's it. Is this clear? Okay. Now, I'll take this away. I'll take all these examples
Doctor,
Yes.
this F is AB E0. Yes,
What F?
AB1.
Which F?
The one you raise it.
Raised. You mean like SF, for example? The
Yes.
term F now,
Yes, about F.
that's the original shape. Okay. What's the electron domain of this SF?
AB1 E3.
AB1E3, exactly. What's the total electron domain?
4.
4. 4 electron domain. Very important. Did you all understand this?
Yes.
Yes.
I hope so. Now, we're going to study 5 electron domains. 2, 3, 4, 5, and 6. That's all what we have. 5 and 6. Okay. The shape of this electron domain depends on the shape of the electron domain depends on the electron domain. If the electron domain is 2, then the molecule will be straight. I want you to memorize the how is it going to look like. Straight. Okay. And let's apply it here. So if the electron domain is 2, then it will be straight like this. This is example. So what's the name of the geometrical shape? Straight. All right. And what will be the angle in this case in here?
180.
One what?
180.
180, exactly. I want you to know these 2 things. If it's straight, it will be, I mean, if it's the electron domain is 2, what's the shape of the molecule?
Straight.
Straight. What's the angle?
180.
180. Is this clear?
Yes.
Good. Okay. If it's 3, then the shape of the molecule is triangle. So the shape, if it's 3, the shape will be triangle. And the angle here is what?
$30
120.
or 60.
What is it? From here to here?
90.
90. It's not 90.
60.
This is 90. It's not more than 90. 120. You must memorize
135.
120 exactly. 120. Is this clear? All right. Now, example is this example. In this case, we are drawing it now here as if it is straight, but the actual shape of this molecule, okay, the actual shape of this molecule will be what?
Triangle.
Oxygen, like this, and the electrons will take a shape like this. I'll draw the electrons as orbital. So what will be the angle in here approximately?
120.
120. Is this clear? I want you to memorize the name. And what's the name of the shape? The shape of the electron domain, what is it? The
Triangle.
Name. Triangle. You have to know this. Good. When we have 4 electron domain, then you must memorize the name. I don't know if you heard this or not before. It's called tetrahedral. Tetrahedral. And the shape of the tetrahedral is the shape of the tetrahedral. This is the shape of the tetrahedral. All right? And memorize the name. What's the name?
Tetrahedral.
Tetrahedral. You must memorize the name. And what's the angle between these? Actually, also I want you to memorize this angle. It is 109.5. 109.5. You have to memorize this extremely well. Is this clear? Good. Then you have, I hope, tetrahedral. What's the angle for tetrahedral?
109.5.
109.5. You must memorize this angle. Like when you memorize this angle, what was this angle for triangle? 120. And for straight, it is 180. You must memorize the angle very well. Now, if we have 5, then the shape of the molecule will be something like this. Again, I want you, this is, what's the electron domain here?
4.
Domain here is 4. Now the electron domain here is 5. What's the name of this shape that we're looking at? It's called trigonal bipyramid. It's 2 words actually. But I wrote it in one line so we can actually state it. What's the meaning of trigonal?
Shape of triangle.
Triangle. If you can see at the base, it's triangle. Can you see at the base? And what's the meaning of pyramid?
Haram.
Haram. And what's the meaning of bi? Bi. What's the meaning of bi?
2.
ثنائي.
ثنائي. So this is called trigonal bipyramid. مثلث with 2 harams, up and down. If you can see that the base that I'm putting the line in it is triangle. And there is like this is haram from this side and haram from the other side. You see this now? All right. So what's the name of this shape? It's called what? Name. I don't need to hear you.
Trigonal bipyramid.
Pyramid. Okay. What's the angle between the triangle, which is here?
120.
120. Exactly. What's the angle between this one and this one? The pyramid and the base. What's the angle?
90.
90. So we have two important angles here. In here we have only one important angle, which is 109.5. In this shape we have two important angles. 120 in the base and 90 on the between the top and the base, or the bottom and the base. These are all 90. Okay, last one, electron domain, is called this shape, and it has 6 atoms around it. All right, it's actually a square. We can think about it as square by pyramid. Square by pyramid. So what is it actually? It's a square. What's the meaning of by?
2.
And what's pyramid?
Half.
All right, so it's a square by pyramid. Okay, there is another name, more important name, it's very well known. It's called, I want you to memorize this name in particular, octahedral. Octahedral. You must memorize the name. It exactly means square by pyramid, but people use octahedral to describe this shape. What's the angle in here between in the square? What's the angle in the square?
90.
What's the angle between the top and the square?
120.
No.
195. 109.5.
No.
90 also.
90, Doctor.
So 90. So it is the same from all sides. It's 90 everywhere. So you have to memorize the angle and the name of the shape, octahedral. Octahedral. So very quickly, if we have electron domain of 2, what's the shape?
Straight.
If we have 3,
Triangle.
if we have 4,
Tetrahedral.
yes, memorize the name, tetrahedral. Oh, I will say also one more thing. If it's straight, what's the angle between the bonds or whatever?
180.
180. If it is a triangle,
120.
120. If it's tetrahedral,
109.4.
you must memorize the angle. How about if it's 5? What's the name?
Fregnal by pyramid.
By pyramid. And what's the angle?
120.
120 and
90.
90. So we have 2 angles in this shape. Don't forget. And the last one, if it's 6, what's the name of the shape?
Octahedral.
Octahedral. All right. And what's the angle?
90.
Only 90. These are called the shape of the electron domain. Shape, don't forget this. This is the shape of electron domain. These things, you must sit down today, memorize the name electron domain, and we know how to find the electron domain, right? And you must memorize the relation between how many A and B, and then 2, 3, 4, 5, 6, and then find, you know, the shape. It's straight or triangle or tetrahedral, trigonal bipyramid, you must memorize it, and then octahedral. Octahedral, you must memorize these names and memorize the angles. Don't forget these things. Good? This is easy. Now, so this is the shape here. If it's linear, then the angle is 90. If it's trigonal planar, 120. If it is tetrahedral, 109.5. tetrahedral here. The angle is 109.5. And the way we draw it, actually, I'll do it for one molecule, which is, we usually draw it like this. This is the shape of CH4. And again, what's the electron domain for CH4?
4.
AB4.
AB4, E1.
Zero.
E0.
Zero.
4. What's the name of the shape of the molecule? The shape of the molecule.
Tetrahedral.
Tetra. Don't forget the name. Tetrahedral. And we draw it like this. We draw it like this. All right. If you remember, in Lewis structure, we can draw it like this. This is the Lewis structure. Fine. But the shape, the geometry of the molecule is like this. And we should draw it like this. And we say it is tetrahedral, and the angle is 109.5 between this one and this one. I hope this is clear. Don't, as I said, you must memorize the name and the angle. Linear, trigonal, linear or straight, same word. Don't forget to write linear or straight, same thing. Okay, and then trigonal planar, and then tetrahedral, and then trigonal bipyramid. Okay, and this is octahedral. You must memorize the name very well. All right? Is this clear? Good. Now, let's look at other things. If we have in the shape of the molecule, okay, I'll give you two examples and then I'll discuss things with you. Let's, for example, if we have B, if, all right, and then we have S, O, and then what's the electron domain for VF3?
AB3. E0.
E0. Yes. How about SO2?
AB2 or E1.
AB2E.
1.
1, exactly. So what's the total around A?
3.
And here?
3.
Okay, so what's the shape of both of the molecules? The electron domain shape?
Trigonal planar.
Trigonal planar. Trigonal planar. It should be. Okay, all right. What's the angle in here?
120.
120. Of course, what's the angle? This angle and this angle.
Also 120.
All 120, 120, and 120. It was found that the electron pair, which is like this, all right, will take more space than the bonds. Okay, so as a result, you will find this angle is slightly less than what? What's the angle here if we have electron domain angle?
Less than 120.
Yes, it should be 120, but we find that it's actually slightly less than 120. Less than 120. Okay, one more thing. The shape of this molecule is exactly trigonal planar. Right? The shape of this molecule is also the electron domain shape electron domain shape is what? Trigonal planar. Okay, but we cannot see the electrons. I mean, in our instrument and our real life, we cannot see the electrons. So what are you going to see then? We will see the shape of the molecule like this. What's the name of this shape?
Trigonal plan.
No, it is called bent, منحني, or V shape. And the angle is here less than 120. Less than 120. Is this clear? Any question?
Doctor, bent
Yes.
and V shape only for S.
Yes.
With
Yes.
F is 120 only.
What?
With BF.
Oh, yeah, as I said, the problem is we cannot see the electrons. That's why I took the electrons away here. They are available, but we cannot see them. I'll put them very small. They're available, but we cannot see them. And that's why the shape of the electron domain is still the same. It's trigonal planar.
Yes.
Shape of the electron domain. But the shape of the molecule is bent or V shape.
Okay.
And the angle is less than 120 in this case. Why? Because the electron take more space than
The bond.
the bonds, but we cannot see it. Is this clear?
Yes.
Very good. Now, let's go to the other shape, which is tetrahedron. And that's what we just talked about. This is, I gave you example of this one, like BF3. BF, F, and this one is SO2. SO2. This is SO2, something like this. Now, if we have CH4, C, H, 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 H. What's the electron domain? Electron domain. A.
4.
Before E0.
4 E0. So what's the shape of the electron domain? Tetra. What? Tetrahedron. What's the angle?
109.5.
You must memorize this and the name. And is this true for CH4? Yes, because there is no electrons, so we can see everything. Is this clear? Is this clear?
Yes.
Now, let's go to NH3. N, H, 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 and we have 2 electrons here. I will draw them at this time like this. So, what's the electron domain for NH3?
AB3.
A,
E2.
E what?
1.
1. What's the,
E1.
what's the total?
4.
4.
What's the shape of the electron domain?
Tetrahedron.
Again, no change. The shape is tetrahedral. Tetrahedral for the electron domain. Okay, and what's the angle in here? take more space than the bonds. As a result, what will be the angle in here?
Less.
What?
Less than 109.5.
Is this clear? Is this clear?
Yeah.
All right. And then we cannot see, as I said, we cannot see the electrons. So what I'm going to do, I'll take the electron away. So what are we going to see in this case? We're going to see this shape. This shape. The name of this shape now, trigonal pyramid. Trigonal, because there is triangle at the bottom here, and one out, which is pyramid. It's not bipyramid. A trigonal pyramid, one pyramid. You must memorize the name. All right, good. Now, let's go to water. O, the water is like this. All right, so what's the electron domain of water?
AB2.
AB, E2,
Two.
E2. What's the total?
4.
4. What's the name of the electron domain?
Tetrahedral.
Again, tetrahedral. Tetrahedral. All right, so the electron domain is tetrahedral. All right, so what I'm going to do, I'll write the water like this, and like this, and then I have electron domain here, and the electron domain, I'll draw it here. Again, the shape is tetrahedral. What's the angle between this hydrogen and this hydrogen?
Less than 100.
120.
Less than what?
109.5.
Yes, still related to 109.5. It should be 109.5. It's exactly if there's no electrons. But the electrons are taking more space, and that's why it becomes less than 109.5. And as we said, we cannot see what?
Electrons.
We cannot see the electrons. So what are we going to see in this case?
Bent.
We're going to see the molecule like this, and so the shape of the molecule will be bent. And what will be, what's the other name?
Trigonal planar.
No, it's not trigonal planar, wrong. What's the other name? V shape. This is clear.
Yes.
V shape or bent, the same one. Some people use
Triangle.
V or bent. It depends on, no, some people use bent, some people use V shape. It's the same. Now, the angle was found here to be 107. In ammonia, the angle was 107, which is less than what?
109.5.
Exactly. The angle in water was found to be, what do you think the angle? Is it going to be 107?
Less.
Less than 107. It was actually found to be 105. You don't have to memorize these angles, but I just want to tell you what was the angle. I want you to memorize this angle. That's the most important angle, which is what? 109.5. Don't forget this angle, which belongs to which structure?
Tetrahedral.
Is this clear? Okay. While in this one, we just, yes. In SO2, what do you think? What's the name? What's the shape of the molecule? SO2, this shape. What's the name of the molecule?
Bent.
Bent or?
V shape.
Shape, similar to water. But what's the angle in here?
Greater than what?
No, less than 120. It was found to be around 117. That's the difference between all right. What's the angle in SO2?
Less than 120.
Yes. And what's the angle in H2O?
Less than 109.5.
Yes. Fantastic. Even though the shape is the same because we cannot see the electrons. The electrons are doing something, but we cannot see them. They are like, as I said, they are available there, but we cannot see them. But I would just want to know that you also know what's the electron domain name for SO2. Electron domain, not the geometry. What's the electron domain for SO2? The electron domain shape.
Triangle.
Triangle. Trigonal planar, actually. Triangles, triangle, but it's better called trigonal planar. Okay, what was the electron domain for H2O?
Tetrahedral.
Tetrahedron. Tetrahedron. Good. Done with the 3 and 4. Let's go to 5 now. If we have 5, like this example, okay, like for example, PF5, P, F, 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 and F. What's the electron domain? Quickly.
AP5.
AB5, E,
E0.
E0. What's the shape of the molecule?
Trigonal bipyramid.
Trigonal bipyramid. What's the angle? We have two important angles. What's this angle?
190 and 120.
And this angle?
90.
Okay, good. Now, when we go to SF4, S, F, F, F. Okay, what's the electron domain shape now?
AP4, E1.
A4, E1. What's the total?
5.
5. What's the name of the electron domain? The name of electron domain?
Trigonal
Pyramid.
Trigonal bipyramid, same. All right. Now, as we said, we cannot see the electrons. All right. We cannot see the electrons. So what are we going to see? The shape that we're going to see إذا تعرفون لعبة الأطفال هذه. تعرفون اللعبة هذه؟
Yes.
اللي ولدي قاعدين وولدي ايش يسمونها؟ ايش اسمها بالعربي؟ بالانجليزي سي سو اللعبة هذه. فشكل المركب the shape of this molecule is seesaw. All right. ايش الاسم بالعربي؟
ما لها اسم.
ما لها اسم؟ ليه؟
هذا دكتور حق اللي وزن اللي الوزن ينزل واللي
ارجوحه
على
اسمها
وزن
يا دكتور.
يرجع.
ها؟
ارجوحه اسمها.
حقت الاتزان دكتور اللي اثقل وزن ينزل وكذا.
بالضبط. بس هم يتعمدون العيال يطلع وينزل يدفع برجوله على اساس تتحرك يعني الارجوحه هذه. Anyway, yes, ارجوحه maybe I am taken, but I wanted to memorize the name. It's called seesaw shape. You must memorize the shape. Now, what's the angle in here?
Less than
180.
Less than what?
20.
Yes. And what's the angle in here?
Less than 9.
20.
It's than
90.
than 90. Excellent. All right. Good. I hope this is clear. Now let's go to another shape. Let's go to ClF3. All right. Now, what's the electron domain for ClF3 that I draw?
AB3, E2.
3, E2. Excellent. What's the shape of the electron domain?
Trigonal bipyramid.
You must memorize it. Trigonal bipyramid. Trigonal bipyramid. Is this clear? Okay. Now, we cannot see the electrons. We cannot see the electrons. So what's the geometry of the molecule if we cannot see the electrons? What's the molecular geometry?
T-shaped.
T-shape. Can you see it? It's like T-shape. Exactly. It will be T-shape, similar to this one. Now, what will be the angle in here?
90. Yes.
Less than 90. This is clear. Less than 90. You must know this. All right. Again, last example. Let's take I. If 2 electrons here, 2 electrons here, 2 electrons here. Okay, what's the electron domain for IF2?
E3.
E, what? 3, AB2E3. What's the total?
5.
5. What's the electron domain geometry? Electron domain geometry.
Trigonal pyramid.
Same one like this one, trigonal bipyramid. Is this clear? Now, what's the molecular geometry?
Linear.
Straight.
Straight or linear. Straight or linear. Okay. Now, what's the angle between F and F?
180. Less than.
No, it will be exactly 180. I want you to tell me why it is 180. Because the electrons are from all around. It's like circle in the base. It's around the atoms from everywhere. And that's why the angle will be exactly 120. I mean 180. The angle is 180. 180. You must memorize all these names and as I said, don't forget when I ask about electron domain geometry is different than molecular geometry. I hope so. Good. Let's go to the last one. If we have F and F. This is SF6. Okay. What's the electron domain?
AP6.
A,
E0.
what?
AP6 E0.
E0. Exactly. What's the electron domain geometry?
Octahedra.
Octahedral. Octahedral. Don't forget this. What's the molecular geometry?
The same.
Octahedral. Why is the same? Because there is no electrons. Right?
Yes.
Let me ask you a simple question. What was the other name that is not, I mean, we don't use, but it's octahedral, but it's the other name? What is it?
Square by
Square by pyramid. Good. Is this clear?
Yes.
Good. Now, if we have BRF5, BRF5. BRF5. Then we have F, and electron domain like this. What's the electron domain? Quickly.
AB5.
AB5, E1. What's the total?
6.
6. Don't forget this. What's the electron domain shape? What is it?
Square by pyramid.
No. Electron domain shape. Same. Octahedral. What's the geometry shape?
Square by pyramid.
It's not by.
Square pyramid.
It's one pyramid. We cannot see the other one. Because we said, as I said, we cannot see the electrons. So we cannot see the other one. So it's square pyramid. Square pyramid. Is this clear? Okay.
Yes.
Last example. I'll take xenon. F. 2 electrons. What's the electron domain?
AB4, E2.
AB4, E2. What's the total?
6.
What's the name of the electron domain?
Octahedron.
Yes, the electron domain is octahedral, same name. Okay, what's the name of the molecule? We cannot see the electrons, so what are you going to see? You are not going to see these electrons or these electrons. So what do you see?
Square plano.
Symbol square. Symbol square. Okay, and the angle here will be 90. Is this clear? Do you know how to make now the shape of any molecule, right?
Yes. Doctor,
Okay, very quickly. Let's find the shape of SO3 and ICl4 minus. Quickly. What's the electron domain for this one? For SO3?
AB3 easy.
E0. So what's the electron domain shape?
Triangle.
Triangle. Planar. Same, like triangle. Triangle is acceptable. What's the geometry of the molecule?
The same.
Same. Why? Because there is what?
No electron.
No electron. Very good. ICl4, what's the electron domain?
AB4, E2,
E2.
2.
Excellent. What's the shape of the electron domain?
Square planar.
No. The
Octa.
electron domain shape.
Octahedron.
Octahedral. What's the meaning of octa, by the way?
X.
Octa 8.
octamer.
8.
فهذا بالعربي معناه ذو الأوجه الثمانية، له 8 أوجه. That's why they call it octahedral, by the way. Anyway, and what's the shape of the molecule? The geometry of the molecule. What?
Square planar.
Square planar. You must memorize all of this, which I just explained to you, all of them just a while ago. All right, very good. Now, let's talk about the carbon here. What's the shape? What's the electron domain of this carbon?
AB4.
AB, what?
4.
No.
3.
AB3. E what?
0.
0. So what's the shape around the carbon? What's the electron domain shape?
Trigonal.
Trigonal planar. Trigonal planar. What's the shape around it? Actual shape.
Trigonal planar. Same.
Same. Right? Geometry. What's the geometry?
Same.
Trigonal planar or triangle. Same. Why? Because there is no electrons. Okay, let's talk about this carbon. What's the electron domain of this carbon?
AB4. E0.
E0. So what's the shape?
Tetrahedral.
Tetrahedral. And what is the shape of the molecule? The geometry, I mean.
The same.
Same. Tetrahedral.
What's the angle in here between H and the H and the C here? What's the angle?
109.
19.5. What's the angle between this oxygen and this oxygen?
120.
Yes, it should be 120. You have to be careful with all these angles. That's exactly what you should have. All right. Now I'll talk about polarity. Polarity. What's the word? Polarity. Very important word. Polarity. What do we mean by polarity? If we have A bonded to B, okay, and B is more electronegative than A, then what will happen to the electron? If B is more electronegative,
will be closer to B.
The electrons. And we don't throw an arrow like this. What do we call this arrow?
Dipole moment.
Exactly. Dipole moment. Okay, very good. Now, we say that the molecule is polar. Molecule is polar, right? But let's take one more thing. A, B, B. Okay, same thing. If B is more electronegative than A, then we are going to have a dipole moment here and dipole moment here. Okay, we say that A, B bond is polar, right? If it has dipole moment, then it is polar. Polar means قطبية, يعني في plus وماينس. This is, in this case, there is a slight minus and slight plus here, and that's why it's called polar. Clear? But look at AB2. The molecule is what? Is non-polar. Why?
Because A will be in the middle.
Yeah, but what will happen? This is force, and this is force. And so what will happen to these forces? They are in different direction.
Cancel each other.
Cancel each other. And that's why we say each AB bond is polar, and each the molecule is non-polar. All right. So let me give you example. Is CO bond polar or non-polar? CO bond.
Non-polar.
No, CO. What's polarity of? You remember what was the electronegativity of oxygen? You remember? Sorry, I forgot.
5.
And what was the electronegativity of carbon?
2.5.
Yes, you must memorize this number I told you. Now, is this bond polar or non-polar?
Polar.
Oh, but the whole molecule is
Non-polar.
non-polar. Is this clear? Any questions so far?
Doctor, should we memorize the negativity, electronegativity?
These numbers?
Yes.
Yes, I told you last time, not in this lecture. Last lecture, I told you, yes, you must memorize these numbers.
Okay, thank you.
For certain elements, not for everything. You remember what was the F? What was F?
4.
4.
Don't forget the F. And what's beside it?
3.5.
And then
2. 3.
3. Then
2.5.
and then
2.
2. This is available in your periodic table. Look at them, and I told you to memorize that fluorine is 4, and look at the periodic table and find the rest. And I also ask you to memorize chlorine, which is what?
3.
3.0, and hydrogen?
2.1.
You must memorize these numbers only. The rest you don't have to memorize. But you can compare which one is more polar, oxygen or sulfur. They are above each other table.
Oxygen.
Yes, why? Because electronegativity increase this way. Clear? Now, let me ask you, CO bond, is it polar or non-polar?
Polar.
How about two molecule?
Non-polar.
Non-polar, non-polar. Is this clear? Now, how about if I put C double bond S double bond O?
Why Doctor not polar? No.
Because they will cancel each other like this.
Oh, okay.
How about if I put COS? This bond will be stronger than this bond. And in this case, is the molecule polar or non-polar?
Polar.
Polar.
It is polar. Why?
Because O is stronger.
The forces will not cancel each other. The dipole moment will not cancel. As I said, I put here bigger, and this one I put it smaller. Because I want to say that this force is stronger. Okay.
Doctor?
Yes.
How about if there was 2S in the right?
Okay, if it's 2S in the right.
And 1O on the left.
Like this one. Like this.
No, I mean 2S on the right side and 1O on the left.
Like this?
Yes.
Yeah. Again, is there any polarity in this between the S and the S?
No, it's
No
non-polar.
polarity at all. But there will be polarity between this one. Is the molecule polar or non-polar?
Polar.
Of course.
Polar.
Yes. Now, let's go back to the previous slide. Now, generally, any molecule, if we have the same terminal, by the way, we call always here the atom, the like C double bond O double bond O. Okay, what do we call the carbon? We call it central atom. And what do we call the oxygen? Terminal atom. Don't forget this. Okay, central atom and terminal atom. Any molecule that has the shape A, B, N, E, 0, if B is the terminal atom is the same, terminal is the same, then we have if terminal atom is the same, if we have any A, B, N, E, 0, then it is non-polar. Non-polar. Is this clear? What is N? N equal to 2 or 3 or 4 or 5 or 6. Is this clear? Okay. Also, if we have A, B, 2, E, 3, it is non-polar. Write this and memorize it. If we have A, B, 4, E, 2 is non-polar. Other than these, they are polar. The rest are polar. I did not write them, but if I have, for example, A, B, 3, E, 1, is this going to be polar or non-polar?
Polar.
Polar, because A, B, 3, E, 0 is non-polar, but A, B, 3, E, 1 is not among these three group. And here we have how many in this group? We have 1, 2, 3, 4, 5, plus 6 and 7. So 7, the group, this 7 group is non-polar, and the rest are polar. Is this clear? So let's have some example. If we have CCl4, which is C, Cl, 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 Cl. Is this going? What's the electron domain?
Tetrahedral.
It's A, B, what?
4,
4, E, 0.
0.
Is it going to be polar or non-polar?
Non-polar.
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 Non-polar. Why? Because it goes to A, B, N, E, 0. Is this clear? Look
Yes.
at CCl3. Here we have C, H, acid. What's the electron domain? AB4,
E0.
0. Is this polar or non-polar?
Non-polar.
It is polar. Why?
Different.
The terminal atom.
Terminal atoms are not the same. Terminal atom are not the same. I hope this is clear, and now you can tell if any molecule is polar or non-polar. Don't forget to write this thing and memorize it for tomorrow or for Wednesday. You have to memorize this thing. And the polar, I wrote only one. There are many in polar. Other than these are polar.
Doctor,
Yes.
AB2E3 and AB4E2. should the terminal atoms be the same or not?
Yeah, of course, always. In order to apply this rule, terminal atom must be the same. Terminal atom must be the same. Clear? If
Yes,
you
clear.
the terminal atom, then everything is polar become. Clear?
Yes, yes.
Yes. If it's only non-polar if we have the same terminal atom and we have these shapes. If we have the same terminal atom but we have other shape other than these 7, then it will be different shape. All right. With this, I'll stop here, and as usual, I'll go to the attendance. And let's open the, can see here also copy. Accept responses, and let's come here.
Doctor,
Yes.
I found that I have an absent. I never missed the class.
I will look at it later. Who is this, Ibrahim?
Yeah.
Yeah, I will look at it, and I will see. We'll discuss it at the end of the semester, and I'll try to be lenient with these things, inshallah. Okay, take your attendance, and you can leave as soon as you take your attendance.